ushering in the new age of 3D. The Panasonic 3D-A1. With dual lenses in a compact body and a weight of just 2.4 kilograms. Until now, shooting in 3D required a cumbersome system using 2 cameras and took a lot of time to set up and adjust. But now, the 3D-A1 makes it possible to quickly and easily shoot in 3D from any angle. It's the start of a 3D revolution. When we look at something, our left and right eyes see it from a slightly different angle. For a 3D image, 2 images obtained by the left and right eyes at a different viewing angle, or parallaxe, are required. The brain combines these left and right images to create a sense of spatial depth and 3-dimensionality. To produce easy-to-view 3D images, 6 important points need to be considered. Correct adjustment of the parallaxe, appropriate image composition, vertical deviation, angle deviation, differences in brightness and color, and rotational error. If 3D images are not produced correctly, they may not look 3-dimensional and could cause eye fatigue. Of the 6 points, 4 of them, vertical deviation, angle deviation, differences in brightness and color, and rotational error, are automatically solved by the 3D-A1. When using the 3D-A1, it's thus easy to shoot video in 3D if attention is paid to the remaining 2 important points. Correct adjustment of the parallaxe and appropriate image composition. Here we will talk about these 2 remaining points. When shooting in 3D, the point where the left and right lens's optical axes intersect is called the convergence point. This sets the plane of the 3D picture. Any subject between the camera and the convergence point will appear to float off the screen. With the 3D-A1, moving the convergence point makes it possible to adjust the parallaxe to control the sense of 3-dimensionality and the sense of depth. The convergence point can be confirmed on the 3D-A1's LCD monitor using the mix setting. When viewing the left and right images overlapped, it's the point where the left and right eye images are aligned. The sense of 3-dimensionality and depth can be confirmed by checking the horizontal separation of images to the left and right. The part that floats in front of the screen is where the left eye image is shifted to the right and the right eye image to the left. The floating image is referred to as a negative parallaxe. The part deep into the screen is where the left eye image is shifted to the left and the right eye image to the right. This depth is referred to as a positive parallaxe. If the separation between the left and right images is too large, the parallaxe will be excessive. And a proper 3D effect may not be achieved. To achieve the correct parallaxe requires adjusting the convergence point to keep the parallaxe within the range where the 3D image can be viewed with the correct effect. The appropriate amount of parallaxe varies according to the size of the display. The display size should thus always be considered when adjusting the convergence point, so that the amount of parallaxe is within the appropriate range to achieve a natural-looking 3D effect. If the display size is not known, the amount of parallaxe should be set, assuming the largest likely display size. These graphs show the correct parallaxe range for natural, comfortable-to-view 3D images. The horizontal axis is the display size, and the vertical axis is the maximum parallax range. If the display size is less than about 77 inches, the amount of both positive and negative parallax should be kept to within 3% of the display width. For example, a 50-inch display is 1,100 millimeters wide, and 3% of the display width is 33 millimeters. So for items with either negative or positive parallax, the parallax should be kept to less than 33 millimeters. For a display size of 77 inches or larger, the negative parallax should be kept under 3% of the screen width, and the amount of positive parallax should be kept under 50 millimeters. This table shows the correct amount of parallax by display size. For example, for a 103-inch display, the amount of negative parallax should be within 68 millimeters, and the amount of positive parallax within 50 millimeters. The reason why the parallax for objects that appear to be deep into the screen needs to be within 50 millimeters is that the sense of depth in this direction is created by shifting the left image to the left and the right image to the right. If this deviation is wider than the distance between the eyes, since the eyes cannot diverge and move outward at the same time, it causes eye fatigue. Because the width between the eyes varies among individuals and is smaller in children, it's best to adjust the separation of the left and right images in positive parallax to within 50 millimeters. But even if the parallax is adjusted to within an appropriate range so the images appear three-dimensional, it may still be too strong depending on the subject being shot, so this must also be considered. Now let's see how this works at an actual shooting location. With a tree-lined street in the background for depth, a model will hold a bouquet of flowers toward the camera. To shoot the scene with a convergence point set near the model's face, so the flower bouquet appears to come out of the surface of the display, you should check the parallax to make sure it's suitable for both the negative parallax area around the flowers and the positive parallax area of the tree-lined street. For example, if the final image is to be shown on a 200-inch display, the amount of negative parallax should be limited to within 3% of the display width, or 132 millimeters, and the positive parallax should be kept to within 50 millimeters. If a 25.5-inch production monitor is being used at the shooting location, the parallax can be checked to confirm that the negative parallax is within 3% of the display width, which by converting the 132 millimeters for a 200-inch display is 16 millimeters, and that the positive parallax, by converting the 50 millimeters for a 200-inch display, is within 7 millimeters. Confirm by checking the amount of left and right image deviation. The Panasonic AG-3DA1 2550 25.5-inch 3D LCD monitor is able to display a crosshatch grid. The grid size is equivalent to 6% of the monitor width, so the left and right images can be displayed overlapping. So it's easy to check that the left and right image deviations are equivalent to half the grid width. If the flower bouquet seems to float too far out of the screen, there's no need to change the distance between the camera and the subject. The negative parallax can be simply adjusted by moving the convergence point closer to the camera and away from the model's face. When changing the convergence point to adjust something with negative parallax that comes off the screen, objects with positive parallax are also affected. If objects given depth have too much parallax, the camera can be moved further away from the subject so that the convergence point is near the model's face. But if the camera is moved too far from the subject, the sense of depth may become too weak. Another way to reduce the sense of depth for the tree-lined street is to change the background composition by changing the camera's position, adjusting it so that the amount of positive parallaxe is within the appropriate range. The sense of three-dimensionality in depth, the amount of negative and positive parallaxe, can also be reduced by shooting at a wider angle. In this way, the distance between the camera and subject and the position of the convergence point both need to be within the appropriate range for natural-looking 3D images. This table shows the appropriate range for the distance between the camera and subject, so that 3D images can be viewed with the correct effect. The convergence point and zoom position settings affect the appropriate range. On the 3DA1, the convergence point setting is indicated by C and the zoom position by Z. For example, for a convergence point setting of C60 and a zoom position of Z60, the shortest distance between the camera and subject should be 2.9 meters, and the longest distance from the camera should be 64 meters. A subject shot from a distance of 2.9 to 64 meters can thus be comfortably viewed as a 3D image. For successful 3D shooting, determine the appropriate distance range between the camera and subject. By pressing the 3D guide button on the 3DA1, the optimum distance range between the camera and subject can be displayed on the LCD monitor as a convenient guide for adjusting the parallaxe. When the 3D guide button is pressed, the minimum and maximum distances for a display of less than 77 inches will be displayed, followed by those for a 200-inch display. The distances will change according to the zoom position setting. For display sizes of 77 inches and larger, use the distance range for a 200-inch display as a guide. When composing images in 3D, it's important to take into account the different images provided to each eye and depth cues relayed to the brain. When an image is visible only to one eye, it may cause discomfort to the viewer. Another example is a frame violation, when an image in negative parallax moves outside of the frame. The subject may appear differently in the left and right images, confusing the brain and causing discomfort to the viewer. And for light such as that filtering through a tree or from a car's headlights, as well as objects that reflect light such as glass or water, the light may appear differently in the left and right images. When shooting in 3D, care must be taken in deciding the image composition. To check the left and right image compositions on the 3DA1, the left and right images can be displayed separately on the LCD monitor. Thus, the important points for shooting correct 3D images are correct adjustment of the parallax and appropriate image composition. Careful attention to these 2 points makes 3D filming with a 3DA1 remarkably easy. To produce even better 3D images, a number of other points should also be considered. Let's take a look at a few of them. When shooting subjects with a parallax, if there are extreme differences in contrast in the 3D images, they may appear as double images, depending on the display on which they are viewed. This phenomenon is called crosstalk. It is caused by the right eye's image bleeding into the left eye's image on the display, and the left eye's image bleeding into the right eye's image. After shooting subjects with large differences in contrast, you should check the final images on a 3D monitor. When cutting between 3D images featuring a rapid change in objects having negative or positive parallax, it may not be possible to view the 3D images with the correct effect, and the images can cause eye fatigue. When shooting in 3D, adjusting the convergence point by taking the scene order after editing into consideration will result in much better 3D images. In this video, we discuss two important points for shooting 3D images with the 3DA1. Correct adjustment of the parallax and appropriate image composition, as well as some additional points for producing even better 3D images. By paying attention to these key points, you will be able to use the compact 3DA1 to easily produce natural-looking 3D images that can be comfortably viewed.